Hi everyone, in this video we're going to start looking at section 6.4, which centers around assessing normality. This video series is going to be split into parts because I do have an outside source that I would like you to view on YouTube. That will also be linked in your modules section. So let's go ahead and proceed forward. Our goal for this lesson is to use sample data to determine if it appears normally distributed. So, in other words, we're going to do some checks, and based off of the data that we're given and based off of the 3 tests that we're going to employ, we're going to decide if the data that we're working with can be assumed to be normally distributed. The first test that you're going to work with is the histogram. So we're pulling information from Chapter 2 to help us. We basically just want to ask, is the histogram that you create going to be roughly bell-shaped? So this term is most likely familiar to you at this point. Remember that bell-shaped, we're looking for something that is roughly symmetrical, kind of looks like the Taco Bell bell, or again, as I mentioned previously, if you're a fan of the Hunchback of Notre Dame or really old cathedrals with bells in them, we're looking for that kind of shape. So please be careful when working with small samples. There might not actually be enough information to construct an accurate histogram. Again, if you think about it in terms of a puzzle, if I only give you a small handful of puzzle pieces, it's going to be really hard to form a histogram that is going to be bell-shaped. So it might not necessarily be that the data that you use to construct the histogram is not normally distributed. It just means that you didn't have enough information to construct the histogram so that you had enough information to make that conclusion. The second test that you're going to employ, again, is pulling from Chapter 3 from your text, and that will be the box plot. The guideline is that there should be no more than one outlier in the sample. Okay, that's going to be kind of your test here. Once you've constructed your box plot, and we're going to do this on the calculator, we'll go through that process, you want to make sure that you only have one or no outliers. And then here, note, you can check for outliers by calculating your lower fence and your upper fence. And remember that if you decided to do that by hand, that would be the first quartile minus 1.5 times your IQR. And then for your upper fence, that would be Q3 plus 1.5 times your IQR. Your third test is going to be constructing a normal probability plot also known as a normal quantile plot. I'm giving you both names just in case you decide to do additional research so that you can look up both of these terms to help maybe increase the resources available to you. So once you create a normal probability plot, and again, I know that you don't have any examples as of yet unless you've looked at the textbook, when you're looking at a normal probability plot, you want to make sure that all the points that show up on that normal probability plot lie on a straight line. If so, then we can assume approximate normality. There is a video that I do want you to check out, and it is linked in your module section, but just in case, here is the URL. So before you do that, I just want to go over one more slide, and then I would strongly encourage you, if not really ask you to, watch this 10-minute video about the normal probability plot. The author provides a bunch of examples for you to look at so that it helps you kind of get a feel for what you should be looking for when you're using a normal probability plot or a normal quantile plot to assess normality. So a couple notes. These 3 checks, your histogram, your box plot, and your normal probability plot / normal quantile plot, these are only checks that we are performing on a sample of data. there is still a chance the random variable that you're investigating is normally distributed, even though the sample fails all 3 or some of the tests. It's really basically just you either got a bad sample or you didn't get enough information from that sample in order to definitively say, yep, this is normally distributed. So basically, in the end, you can say based off of the data that you've been provided, you are either able to assume normality or you are not able to assume normality. So again, what I would like you to go ahead and do is go ahead into our module section and watch this video on the normal probability plot. If it helps, it's called Normal Probability Plots Explained, and it's Open Intro Textbook Supplement. That's the full title of the video. Give that a watch. When you are done, go ahead and come back to the next video in this series, and we're going to go through an example problem.